Hello everybody, I hope you're all doing well. We're going to be looking at question 17 in this video. In the diagram, the number line is marked at consecutive integers, but the numbers themselves are not shown. The four larger dots represent two numbers that are multiples of 3. And two numbers that are multiples of 5. Okay. I was worried there because I thought multiple of 3 and multiple of 3 right next to each other. I don't think so. That's impossible. Okay. So 3s and 5s. Which point represents the number which is a multiple of 15? Oh, okay. So we've got two big dots, and then 1, 2, 3, 4, 5, 6, 7 little dots. Big dot, little dot, big dot. All right, let's see if we can... Actually, you know what? I'll color code this. So I'll draw my number line. We'll make the big dots the pinky red color. The little dots will be 1, 2, 3, 4, 5, 6, 7. It was big dot, and then it was little dot, and then big dot again. Okay, so we've got our number line, and then I think it was A, B, C, oops, maybe it was over a bit. Well, before I start labeling things, let's just make sure I have it correct. Yep, 7 in the middle, and then it's A, B, C, D, E. Okay. So the big hint is the big numbers that we've got here. Now, a multiple of 15 is going to be a multiple of both 3 and of 5. So what I want to do right now is figure out which of the big dots are the multiples of 3, which ones then are the multiples of 5. And, you know, if I want to go for multiples of 5 first, that's fine. So if I were to call this N, and maybe this M. So first thing to notice, if I'm hunting down the multiples of 3, I know that these two can't both be the multiples of 3. These two also can't both be the multiples of 3 because they're too close to each other. If you think about the number line, it's multiple of 3, not, multiple of 3, not, multiple of 3. They're spaced out. There's 2 in between them. Okay? So when we realize that, okay, these can't both be multiples of 3. So one of these two is a multiple of 3. The other one must be a multiple of 5. One of these two is a multiple of 3. The other must be a multiple of 5. So what I'm going to do is I'm going to figure out these two N numbers in terms of N and M. Okay? So we get N plus 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is N plus 9. 10, 11. This is N plus 11. How about M? 1, 2, 3, 4, 5, 6, 7, 8. So this is M plus 8. 9, M plus 10. Okay? And having done that, I now say, okay, well, these two are the only ones that differ by a multiple of 3. And these two are the only ones that differ by multiples of 5. So they are the multiples of 3 and of 5. We can even color code them a bit more. Purple will be multiple of 3. And yellow will be multiple of 5. Okay? But every third number is a multiple of 3. Every fifth number is. Now I know where a multiple of 3 is. I can count 1, 2, 3. 1, 2, 3. 1, 2, 3. And I can do the same thing with the multiples of 5. Starting at M, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and we get to the last one. But there's only one number that was colored twice, and it's both a multiple of 3 and a multiple of 5. D is going to be our answer. Okay? And just because I'm ever so slightly paranoid, I just wanted to make sure, yes, A is A, B is B, C is C, D is D, and E is E. Okay. Good. Didn't want any problems like that. So D is our answer, and we move right along with just a little bit of pep in our step to question number 18.